Welcome to WCAD Wonders. This is Ganesh from Bangalore. In this video, let's see how to solve problems that are associated with ratio and proportion. And ratio need not be between just two quantities. So it can be among more than two quantities as well. For example, let's say we want to divide say rupees 300 in the ratio say 4:5:6. Let's say there are three persons A, B and C. We need to divide rupees 300 among them in the ratio 4:5:6. That means what? A should get say 4 parts. If B gets A gets 4 parts, B should get 5 parts and C 6 parts. So what's the total number of parts? So 9 plus 6, 15 parts. That means out of 15 parts, A gets 4 parts. So 4 out of 15. Okay, so which means A's share equal to 4 by 15, because 4 by 15 of the total amount. So 4 by 15 of 300. So here 15 and 30. 2 times 20. So rupees 80. Okay, B share will be, B will get 5 parts. So 5 out of 15. So into 300. So here again, so rupees 100. Okay, C's share will be 6 out of 15. So 6 by 15 into 300, which is equal to rupees 120. 20 into 6, 120. See, for to find C's share, can do this way, or can add these two and subtract from total, because 80 plus 100, 180, 300 minus 180 will give you 120. It can be done that way also. And so you can verify this. You add all of them, you should get 300. Okay, now see ratio. Okay, first two. In what ratio we divide? A, let's say A, okay, is to B. So they get ratio 4:5, correct? So B is to C. Okay, so this is for A, this is B, this is C. So 5:6, correct? See, 5:6 can also be written as, say, 15:18, isn't it? If you multiply each term by 3, we get a 15:18. Okay, let's suppose A is to B ratio is given, and B is to C is given. So how to find A is to B is to C? See, because we know the answer, isn't it? So A is to B is to C is 4 is to 5 is to 6. Okay, but how to get that? So we know A is to B is 4 is to 5, B is to C is 15 is to 18. So here we need to make B term same. So here, see B is here this one. Okay, in the first ratio, in the second ratio, the B term is 15. So how to make them equal? So if we divide 15 by 3, we'll get 5, correct? So B is to C. So in order to make B term same, so divide this one by 3, but so ratio will remain valid. So only if both terms are multiplied, divided, all the terms of the ratio should be multiplied or divided by the same value. So if 15 is divided by 3, 18 also should be divided by 3. So then it becomes 5 is to 6. So now we know A is to B is 4 is to 5, B is to C is 5 is to 6. So which means A is to B is to C equal to 4 is to 5 is to 6. Okay, let's take okay, another one. Okay, suppose A is to B equal to, so take any value, maybe same thing, 4 is to 5, let's take or 4 is to 3, and B is to C. Okay, suppose it's say 12 is to say 5. So now how to find A is to B is to C? So this is given, we need to find A is to B is to C. So again here A is to B, B is to C. What is common here? B. B is common. So we need to make that common term same. So here 3. So how to make them equal? So this will be equal if we see divide by, see there are two ways. Say one is if we divide 12 by 4, we'll get this, we'll get 3, or if we multiply 3 by 4, we'll get 12. So we can do any of this. But see, if we divide 12 by 4, then 5 also, this term also should be divided by the same number by 4, but it's not divisible. We will get a fraction, correct? So let's try the other one. Let's multiply 3 by 4. So in that case, so other term, that is 4, also should be multiplied by 4. Okay, so now a is to b can be written as 16, multiplying each term by 4, where 16 is to 12. So a is to b 16 is to 12, and b is to c is equal to 12 is to 5. So now, so because now b term same in both the ratios, so therefore we can write the ratio among a, b and c, or a is to b is to c, as 16 is to 12 is to 5. Okay, instead of a is to b is to c, suppose we are asked to find the ratio between a and c, or a is to c. So what is a is to c? See here, this is this represents a, this is c. So 16 is to 5. That's all. Or we are, suppose we are asked to find only a is to c, not we don't require a is to b is to c. Then there's the easier way. Because a is to c is nothing but a by c. See, a by c can be written as a by b into b by c, isn't it? Because a by c equal to a by b into b by c, because b will get cancelled, a by c. Okay, see now we have both the values. See a is to b is 4 is to 3, so that means a by b is 4 by 3. So 4 by 3 into, and b by c is 12 by 5. Okay, if we simplify, what we get? Here 3 and 12, 4 times. 4 into 4, 16. 16 by 5. That's all. So a by c 16 by 5, which means a is to c equal to 16 is to 5. Correct. See, we got this ratio. Okay, let's solve some more problems. Okay, let's see something interesting here. Let's say the bag contains say some coins, say 1 rupee coin, 2 rupee coins, and okay, 5 rupee coins. So the 1 rupee coin, there are how many? Say 12 1 rupee coins. Here, say 4 2 rupee coins, and let's say 6 5 rupee coins. So what's the total, say, amount in the bag, or value of the money in the bag? Say 1 rupee coin at 12. That means 12 rupees. 1 into 12, correct? Say 1 into 12. This number of 12 rupee, value of 1 rupee coins is 12, this one, and value of 2 rupee coins is, say, 2 into 4, and value of 5 rupee coins is 5 into 6. So which means 12 plus 8 plus 30. So 12 plus 8 is 20 plus 30, 50 rupees. That means the bag contains 50 rupees. Okay, let's frame a question based on this. Okay, if the question is like this. Say a bag contains some 1 rupee, 2 rupee and 5 rupee coins. The total amount in the bag is 50 rupees, and the number of, the ratio between the number of these coins is, what is the ratio? 12 is to 4 is to 6, correct? If you simplify, what we get? So both are all are divisible by 2. So you can say 6 is to, so what is the ratio? So 6 is to 2 is to 3. Okay, so the number of so ratio between the number of these coins is 6 is to 2 is to 3. So find the number of coins in each denomination. Find the number of coins of each denomination. So each denomination meaning each, that is how many 1 rupee coins, how many 2 rupee coins, and how many 5 rupee coins are there in the bag, so that the total value of the coins is rupees 50. So how to solve this problem? Okay, we know the coins are, say, 1 rupee, 2 rupee and 5 rupee coins, and the ratio 6 is to 2 is to 3. Okay, so let's solve like this. So let number of say 1 rupee coin be 6x. Say number of 2 rupee coins 2x, and number of 5 rupee coins 3x. Okay. So now we know total value is 50. So how to find the total value of these coins? See 1 rupee coin 6, 2 rupee coins 6x, 2 rupee coins 2x, and 5 rupee coins 3x. So value of 1 rupee coins is 1 into 6x. Value of 2 rupee coins is 2 into 2x. Value of 3 rupee coins is 5 into 3x. Okay, but we know the total is 50 rupees. Okay, let's solve this and find the value of x. So 6x plus 4x plus 15x equal to 50. So 6 plus 4 10, 10 plus 15 25. So 25x is equal to 50. Okay, which means x is equal to 50 by 25 2. So x is 2. Okay, therefore number of 1 rupee coins is 2x. So which is 2 into 6 12. Number of 2 rupee coins is 2x, so 2 into 2 4. Number of 5 rupee coins is 3x, so 3 into 2 6. See, we have found it. So this is a number of coins of each denomination. Okay, let's combine this HCF and this ratio. Okay, the question is the ratio between two numbers is 5:9. Okay, find the numbers. Okay, if their HCF is 16, so how to find this? Okay, so we know since the two numbers and the ratio 5:9, we can take the numbers as 5x and 9x. So let the two numbers be 5x and 9x. Okay, we know the HCF is 16, that's given. So what's the HCF of these two numbers 5x and 9x? How to find? So already seen in the while discussing the concept of HCF. So to find HCF, what to do? So whatever see numbers, whatever common factors here, say what is here, say x is common in both. So you need to take the, for the common factor, we need to find the take the least power, isn't it? So x is x power 1. So just x. And what is the common? Is there any common factor between 5 and 9? No. Correct. So HCF is just x. HCF of 5x and 9x is x. So which means x is equal to 16 because it's given HCF is 16. So therefore the two numbers are, see what, 5x and 9x. So 5 into 16 and 9 into 16. So which means they are 80 and 144. So these are the two numbers. So you can verify their HCF will be 16. Okay, suppose see the numbers are okay 6x and so say what is that 15x. So HCF is, so HCF of the numbers, what is HCF of 6 and 15? It's 3. And for the numbers here, for the variables x, so it's 3x. Suppose it's 6x square and say 15x cube. Then again, so highest common factor HCF of 6 and 15 is 3, and for x square and x cube, so HCF is, you need to take the least, the one with least power, so x square, 3x square. So this is the HCF. For LCM, you should take the highest power. For example, HCF LCM of 6x square and 15x cube is, so LCM of 6 and 15 is what? It's 30, isn't it? So its LCM is 30, and here x cube. You have to take the highest power when the, say among the common variable, say x is common in both, so you need to take the highest power, so 30 x cube. So that's the LCM. So for 6x square and 15x cube, HCF is 3x square and LCM is 30x cube. Okay, let's see more in our next video. Thank you.